Well, a lot of people think that engineers can only learn about technology, but I've learned a lot this morning. And what I'm finding is that I'm more confused than ever. My wife, when we had to choose those adjectives, my wife said that I was sometimes disruptive. My students say I'm difficult. My kids think I'm dopey. So I guess we'll just have to see how this goes, and you guys can decide for yourselves. But I'm here to talk about photovoltaic energy. We all use energy all the time. Specifically, my interest is electrical energy, where we get lighting and power for our cell phones and all of our electronic devices. And what I want to talk about today is how there is truly a revolutionary change in how we're going to get our electrical energy even today as we speak. What you see here on this slide is a picture of the photovoltaic array we have on the roof of Daktronics Engineering Hall. And this is something that anyone in the community can see if you get far enough away from the building, because it's way on the top of the roof. But if you want to get a tour of this, it's available and we can explain to you how it works. But we have enough photovoltaics on that building to operate roughly about 4 homes. So I'm told that I have to make this for a general audience, which is really hard to do. So the first thing I was told is you got to have a lot of pictures. So here's some nice pictures of the traditional applications that probably you're all familiar with. We have the Hubble Space Telescope, space station. All of these applications use photovoltaics because they're off-grid. Photovoltaics has never been cost-effective until now for on-grid applications. The next slide is for the English majors. There's no pictures because I've been told that words are very powerful. So there's 3 key points that I hope you'll remember when I'm done here. The first is people don't sometimes realize how much solar energy falls on the earth, but I think most of us know that life comes from the sun, and 1 hour of sunlight can power the entire electric needs of the world for a year. So the energy is there. It's just never been cost effective. What's new is that second bullet. Since the solar cells were invented at the time of the microelectronics revolution around 1954, 60 years later, we've had that amount of time to finally get the cost down to where it's competitive with other sources like nuclear in particular here. And what we like to say from an engineering perspective is that solar energy is at grid parity. So what that means very specifically is that you folks in the room or Daktronics can install photovoltaics at their location, and it'll cost the same as what they're paying Brookings Utility or Xcel or whoever you're paying your energy for. Now, utilities is a little bit different picture. Utilities don't like solar energy because if they're required to be green, it's actually more expensive than the more traditional sources, and I'll talk about that a little bit more. So here's the current picture. I think most of us know there's an awful lot of fossil fuels that are being used even today. So the concern is obviously global warming, air pollution. We need renewable sources that don't emit carbon dioxide and all the other gases. Today's world, only about 8% of our energy is renewable, and most of that is very traditional, hydropower in particular. So if the way at the top here, you see solar is less than 1%. So that's really the good news, is that we have a huge opportunity to improve our climate by using probably the cleanest fuel that's available today. So these are the advantages. I think probably most of you have seen most of these. It's clean. Unlike wind, it's very quiet. It's the quickest system to build in terms of environmental work statements and those sorts of regulatory concerns. Probably the new one is the last 2 that you're not familiar with. Solar energy is distributed. That means that it actually makes the most sense to put it where you're using it. That means on the roof of your house or the roof of an industrial building, or the roof of Walmart, wherever. And that reduces the need for the electric grid. So there's also savings from that perspective. Now, a lot of people are worried about covering the earth with solar panels. To power the entire needs of the United States, you only need about 100 square mile section. And there are plenty of places that we can put that. For example, Texas, they have so much land down there that I don't really think they'll mind. But if they don't like it, you can put it in the desert. You can even float it on the ocean. So there's all sorts of opportunities. The other interesting point here is about a third of that area is equivalent to the roofs on our houses in the U.S. So you don't need all that space for land space. You can actually use existing roof space. The other thing you need to look at when you want to think about solar is where is the solar energy relative to various places in the country. And obviously there's more solar energy down in the Southwest than in South Dakota, but we have about average. We have what are called 5 peak sun hours a day. So even with that rate of sunshine, solar energy is cost effective. Why don't we see it other than on the top of Daktronics Engineering Hall in South Dakota? I think that's probably one of the biggest installations in the country. And the reason has to do with economics, as with most things. Our energy costs are some of the lowest in the country, and we also have a lot of other good renewables. So the colors on these states here tell you how green the states are. We're one of the top 5 greenest states because we have hydro on the Missouri River and we have a lot of wind. So it's going to come to us last, but the message here is that it's coming. This is probably the most important slide I've got in the slide deck. This is for the engineers because we absolutely love graphs. It's going to take me about 10 minutes to go over this, but on this axis here we have electricity prices. On this axis we have the cost of solar. These are the costs of the solar panels. This is back in 2006. Remember, in 1954, they were about $70. But the cost has dropped exponentially, and this graph was put together by a bunch of investment bankers. They wanted to know when the cost of solar would equal the cost of grid energy. This is the grid energy here, and it's going up because of inflation. The hot spot here is the convergence, and if you look down, that's today. And in fact, this graph was developed in 2009. We actually beat this. I think it was actually convergence on a national basis last year. People ask about wind. Wind has had exponential growth, but you can see it's slowing down, and solar is actually accelerating because of that cost equation. Solar now can be less expensive than wind. This is Germany's picture, and I'll talk a little bit more about Germany, and this is the U.S. picture, the same basic story. So some forecasts that can be somewhat dramatic, but I think will come to pass, about all new generation capacity in this country is photovoltaics because it's so quick to install and the cost. And most people predict about 30% of our energy or electricity will be photovoltaics in 20 years. California actually mandates 20% by the year 2020. And solar energy will make up 100% by 2100. And as you can see, we're ahead of schedule here. So some really interesting, somewhat startling facts. So where are we compared to the rest of the world? Well, the leaders in photovoltaics are Germany and Japan. U.S. is down here. Why is that? Simply because they have much higher costs of fossil fuels. They have to import a lot of their energy. We're blessed with a lot of our own fossil fuels. How do you do it? It's pretty simple. You've probably seen pictures like this now. They're becoming more and more common. You can install it on the roof. If your wife won't let you do that, like my wife doesn't really want to see it in the front of the house, you put it in the backyard or put it where you keep the horses. You can put it just about anywhere you want. One of the popular things now is if you don't have space in your yard, we use community solar. You could put it up where the Brookings gardens are, for example. And this is a good example of what we could do right here in Brookings. You could cover Brookings gardens with solar panels, and people find that as long as you don't cover more than 30% of the area, it doesn't affect crop growth. And this allows shading for the people that are playing with the plants. The second type of photovoltaics is commercial, right? Walmart is a leader. These are some nice pictures I found on the internet from IKEA. So you can cover your building. Another very popular application is to cover parking lots. It keeps the snow off the cars in the winter, and it keeps the sun off in the summer. This is one of the earlier utility scale systems that Germany put up. So you have 3 different types you can see. All of these markets, so this is utility scale, this is commercial, and this is residential, are growing exponentially. But it's really only these 2 that are cost effective. For the utilities, it has to replace traditional fossil fuel. So the reason you see that growing is because of mandates like in California or Minnesota, where utilities are required to have a certain amount of renewables. So this is the on-fire part of photovoltaics. We have this many large-scale plants in the U.S. today. Notice again that where the high cost of electricity is on the coasts. South Dakota doesn't have any yet. And when it's economically feasible, which will probably be soon, we'll see them there as well. So these are kind of the takeaways. Photovoltaics is cost competitive now. You can be green and it doesn't cost you any additional money. You can, if you want, disconnect from the utilities or reduce your use of utility power. But, you want to be ready for some discussions with our utility folks because they're going to be nervous about the loss of revenue. So a lot of people say what's happening in the field of energy today in the grid is very similar to what happened in the communications world. 20 years ago, AT&T was broken up and deregulated, and we evolved from a landline system where everybody was connected through central offices to the cell phone era. And the same thing is happening now with power. We no longer need the big centralized power plants. Everybody can have either their own solar system on the roofs or community solar and get away from these large grids. So my last slide is my vision of Brookings. Right? Everybody can have a solar panel on their roof. And I try to convince the architecture folks that solar panels are beautiful. You know, they look like a lake or the ocean on a nice day. They reflect the blue color of the sky. All right, thank you very much. Engineering hall. And this is something that anyone in the community can see if you get far enough away from the building because it's way on the top of the roof. But if you want to get a tour of this, it's available and we can explain to you how it works. But we have enough photovoltaics on that building to decide for yourself. But I'm here to talk about photovoltaic energy. We all use energy all the time. Specifically, my interest is electrical energy, where we get lighting and power for our cell phones and all of our electronic devices. And what Well, a lot of people think that engineers can only learn about technology, but I've learned a lot this morning. And what I'm finding is that I'm more confused than ever. My wife, when we had to choose those adjectives, my wife said that I was sometimes disruptive. My students say I'm difficult. My kids think I'm dopey. So I guess we'll just have to see how this goes, and you guys can... What I want to talk about today is how there is truly a revolutionary change in how we're going to get our electrical energy even today as we speak. What you see here on this slide is a picture of the photovoltaic array we have on the roof of Daktronics